Okay, this is the M1 paper from June 2023. It's question number 6, and when we get far enough through this question, we'll see it's a statics question. We've got all these forces acting in equilibrium. We're going to be told that the particle doesn't move. Let's have a look at the question though. It says we've got a particle of weight W newtons lying at rest on the surface, as in the diagram. Force P newtons is there. And then this is the part that I'm going to focus on first of all. It tells me that alpha, or rather tan alpha, is equal to 4/3. So they do that a lot in the diagrams. Let's just tidy that bit up first of all. Really straightforward, but we just need to address it. If tan alpha is 4/3, then I can say that's opposite over adjacent here. Well, I can set up this right angle triangle, the 3, 4, 5. Use Pythagoras if necessary, but 3, 4, 5 triangle here. So I can now say, well, I can see that tan alpha is 4/3. They've told me that. But I can work out that sine alpha and cos alpha, well, sine alpha is opposite over hypotenuse, so that's 4/5, and cos alpha is adjacent over hypotenuse, so that's 3/5. Okay, let's return and actually do the force diagram for this situation. So if we set up our rough surface here, my particle, it told me, has got a weight of W. Obviously, it will have a reaction force as it's sitting on a plane here. We had this force P, which is acting at an angle of alpha there. So what we can do is to resolve this horizontally and vertically. This is going to be P sine alpha. Let's put one P on there. This is going to be P cos alpha. And then if that force P is acting in that direction, if there were movement, it would be in that direction, which means the frictional force, which is opposing motion, should be in the opposite direction there. Right, so once I've got that then, we said that there's no movement, so let's resolve vertically. So if I resolve vertically, what have I got? I've got my W, my R, and my P sine alpha there. Well, they're all going to balance out, so F equals ma. There's no acceleration, so I can say that R is going to be equal to P sine alpha plus W. The upwards forces equal the downward forces, and we know that P sine alpha is is 4/5, so R works out to be 4p/5 plus W. Okay, now let's look at F equals mu R. So F is going to be equal to, what do we have mu as being? Mu as a quarter. So F is going to be a quarter of 4p/5 plus W. We'll leave it like that. And then let's resolve horizontally. Go back and have a look horizontally then. What have we got? We've got, we want it not to be able to move. So it's not going to be able to move, then the F has got to be greater than or equal to the P cos alpha. Let's get rid of those blue ones here. We're looking in this direction now, and if it doesn't move, then the friction has to be able to overcome that P cos alpha. So for it not to move, we want that F has got to be greater than or equal to P cos alpha. Remember, cos alpha was 3/5, so we're going to have F is greater than or equal to 3p/5, and then that's a quarter 4p/5 plus W is going to be equal to 3p/5. Now we just need to tidy this all up. So let's get rid of that quarter, multiply everything by 4. So I'm going to have 4p/W plus, 4p/5 plus W is 12p/5. I've multiplied out by the 4 there. And let's put the signs back in. Don't know why they suddenly became equals. And so W has to be greater than or equal to 8p/5, and we wanted P, so P 5W/8. Let's just write that the way that they've actually said it. They've said that P is less than or equal to 5W/8. and that was what we were asked to do in the question. So relatively straightforward question, just going through all the various different processes, and that should really have been straightforward for you. Hopefully that all makes sense.